gosh, hey Michelle, what's up?
Oh my gosh, hi! I'm actually about to start nerding out with the dataset about high school GPAs.
Wait, that's so cool. Can you show me how to do it?
Yeah, of course. Let's switch over to my computer and get started.
Okay, let's get started. So we're going to start by creating a new repository by going to github.com/new. And then what we're going to do is basically just go through all of these steps. So I'm going to select an owner. I'm just going to make it myself. And then repository name. They have a suggestion right here, but let's make it a little bit more descriptive. So let's do Discovery MicroProjects. Okay. And then I'm not going to put a description for now. I want to switch mine over to private though. And then I will do this checkbox to add a README file. And yeah, let's create the repository. Here it is. And so this is the repository that we're going to be using for all of our microprojects. Okay, so our next step is to clone our Git repository. And we're going to do that in VS Code by first clicking on Clone Git Repository. And then they're going to ask us for a repository URL. So we're going to go back to GitHub and copy over the URL of the repository we just created. And then we're going to go back to VS Code and then paste it into here. And then select repository destination. And then we're going to open it up in a new window. And so here is our repository in our own VS Code. And then our last step is to add the MicroProjects remote. And so what we're going to do is go over to this link right here. The MicroProject setup specifically, and we're going to basically use this command to add the MicroProjects remote. So I'm going to copy it over, and then I'm going to go back to VS Code and then open a terminal. And so if you've never done that before, you basically at the top there should be a taskbar where you can do terminal, new terminal on Mac, and then we're going to paste this command over. And then if we don't see an output and there's like a little a little green dot, then this means that it worked. Okay, so now that we've set everything up, we are ready to start our first ever microproject. This one is called Trends in High School GPAs. And so what we're going to start by doing actually is fetching our initial files. So we're going to basically run these two commands in our terminal. Same one as before. It's going to probably take a second, but once that's ready, we've basically copied over our initial files. And as you can see, we have these two new tabs that just popped up. And so if we go into here, we're going to actually find the first ever microproject. Isn't that so fun? Let's jump right in. So the data source that we have right here is the Common Dataset, or CDS, and it's an annual report published by nearly every major college and university in the United States with the goal to achieve the development of clear standard data items and definitions in order to determine a specific cohort relevant to each item. And so the main things that we're going to focus on is GPAs. And so if you look right here, they show kind of like an example of the data that is given. So, for example, the University of Wisconsin-Madison gives the following high school GPAs. So as you can see, we have high school GPA and percentage of freshman class. So about 47.8% of people going to UW-Madison as a freshman had a high school GPA of 4.0, and then 83.8% had one of 3.75 and above, and then similarly 95.9% had a GPA of 3.5 and above, et cetera, and then everyone, 100%, had a GPA of 2.5 and above. Okay, and so it looks like for this microproject, we're basically going to explore some trends with high school GPAs and freshmen at Big Ten schools. So starting with part one. So the first thing that we're going to want to do is to basically import the CDS Big Ten high school GPAs dataset. And so this is going to basically use some of the information that we've learned during class or previously. And so the command that we're going to do here to actually load this URL as a data set, as a new data frame in a variable named df, is we're going to delete this dot to dot. And we're going to do, obviously, we're going to import pandas. And then what we're going to do is we want to call it df, right? So we're going to do df is equal to, and then we're going to do pd.read, because remember that is the, actually read CSV, sorry. That is the command that actually gets us to basically read in the data frame. And then they gave us the URL here, so we can actually just copy paste it over and then put it into quotes. So if we run right here using this run button and do Python environments, 3.9.6 is fine. And then it's going to take a second to run, and then the green check mark means that we have no compilation errors or anything, so hopefully this worked. And so to actually test to see if this has worked, we're going to basically do this down here. And as you can see, our data frame has loaded, and we can see a bunch of different rows. Looks like there's 186 rows total and 13 columns. And we can kind of take a look at this data. So we have the school, and then I guess these are the percentages again. And then it also gives us the average and the percent of students report GPAs. So this looks pretty good. Okay, moving on to part 2, exploring the data. And so the first thing that we want to do for 2.1 is find the highest percentage of freshmen with 4.00 high school GPAs. So what they want us to do is find the 10 rows that have the highest percentage of incoming freshmen with a 4.00 GPA. And they want us to store these 10 rows in a new variable named df_highest 400. Okay, so the first thing that we're going to do is to actually find the structure of the data set. So the column that we want to do is the percentage of freshmen with a 4.00 GPA. So this one is going to be called equal to 4.00. So that's the name of the column. And the reason why we're doing this is because Python is very, very specific about the exact name. So even if we were to like add a space in between equal and 4, like the 4, it wouldn't be able to recognize it. So we want to find the exact formatting. So equal 4.00, that exact one. So I'm just going to copy it onto my clipboard. And then to find the highest 10 rows, we're going to use a function called nlargest. So df_highest 400 is equal to df.nlargest, and then we want the top 10, right? So it's going to find the first n row, so our n is going to be 10, and then our second argument is going to be the name, so it's going to be basically equal 4.0. Again, make sure that the formatting is exactly what the name of the column is, and then if we run this, it should display, okay, the 10 rows. So it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have the 10, and most of it is UCLA and UW-Madison. Okay, cool. And so this next step is basically a test case. So this basically will test whether or not we've done that correctly. So let's run it. Oh, okay. It says all tests passed, which means that we did this correctly. And so now we're ready to move on to part 2.2, which is exploring the UW-Madison data. And so what it wants us to do is we want to select all years of data from University of Wisconsin-Madison. And so what it wants us to store is the rows with data about University of Wisconsin-Madison in a new variable called df_Wisconsin. So the way that we're going to do this is by actually going back to our data. So let's think about it like not from a coding standpoint. Like if I were just to see this entire data set and like do it manually, what would I do? Well, I'd probably go through all 165 rows of this and then look at like what school it is and see which ones have University of Wisconsin-Madison. And actually that is exactly what we're going to code. And so what we're going to do is we want to select all of those schools where the school is equal to University of Wisconsin-Madison. And so I'm going to basically copy over this name. And so basically what we're going to do is we're going to go through the data frame and select all of the ones where df.school is equal to the University of Wisconsin-Madison. And so how I got that is the name of the column is school. So I want to do df.school, and then I want to check to make sure that that school is equal to University of Wisconsin-Madison. And so if we run this little section of code, we can see our visual output, which looks like all of these are University of Wisconsin-Madison. And so it's a bunch of different rows starting from the year 2000 all the way to 2023. And then let's run the test case to make sure that we did it correctly. All tests passed, that's a good sign. Okay, so now we're gonna move on to part 2.3, which is exploring data from UMichigan now. And so they give us a command, df with column.unique. And so what that does is it gives the unique values of a given column. And so they want us to find all the unique values for the column school. So we can copy paste, we can just type df, and then the column name is actually going to be school. So wait, where'd it go? df school, oops, dot unique. And then if we run it, it's going to give us an array of basically all of the different schools that we have. And so we have UCLA, Indiana, Iowa, et cetera, et cetera. And so now that we have a list of all the university names, they want us to find the exact spelling and capitalization for the University of Michigan. And so this basically is going to be, let's look for it, University of Michigan. Okay. And so what it wants us to do now is to basically select all of the rows from the original data frame that contain information about the University of Michigan. So I'm a little bit lazy, so I'm just going to copy paste. I've noticed that this is basically the same thing that we've done before, but with Michigan instead. So I'm going to kind of just copy over the same command that we had before, but I'm going to replace it with Michigan instead. So again, I want to grab the exact name that we have for University of Michigan, and we're going to put that right here. And so let's run it and see if it works. Okay, and looks like we have all of the University of Michigan rows. And then let's run the test case to see, okay, all tests passed, that's good. Okay, and then the last step for this part is to create a variable for one final school. Let's do Michigan State. So I'm gonna again just go back here and copy paste the same code over. And then what we're gonna do is we wanna check the exact spelling of Michigan State using this array that we've had right here. It's just going to be Michigan State with the first letter capitalized. Let's go back down. Oh, past it. It's right here. And then we're going to do Michigan State. And if we run it, we're going to see all of the rows with Michigan State as the school. Okay, so let's run one more test case to make sure that we've done this correctly. All tests passed, it's a good sign. And so I think that means that we're ready for the next part, which is actually the final part, data visualization. And so in the past 3 parts, we've basically been able to create 3 data frames for Wisconsin, UMich, and Michigan State. And so when we're creating any visualization, we want to first figure out what our axes are going to be. So let's start with the x-axis, right? And so to understand some kind of trend over time, we typically want to visualize the year on the x-axis. And so it wants us to find the column name in our data frame that contains the data for the year of the data and then store it into the Python variable called xcolumn. So let's go back all the way up to our initial data set, or any of the data sets, honestly. So as you can see, the name for the year column is year space parentheses fall parentheses. So let's copy that over just because I don't want to type incorrectly. And then so let's put this into quotes and run it. So yeah, that's going to be our X column name. And then so for our Y column, we're going to want to find the name of the column that contains the data of the percentage of all freshmen who have at least a high school GPA of 3.5 or greater. So let's go back up to one of the data sets. We're looking for a GPA of 3.5 or greater, so that's going to be greater than or equal to 3.50. And then let's go back down and copy that into here with quotes. And then let's run it just to display it and make sure we did it correctly. Okay, looks good. And so now we're ready to create the visualization. And so it looks like they've already given us some of the code, but let's walk through it. So our first line makes basically a line plot using our data frame for Wisconsin that we previously created. So that's df.wisconsin. And then we also made Michigan and Michigan State. And then they're going to do the x column as our x column variable, and then y column as our y column that we previously created. So 3.50 and then the year fall. And then it looks like we're setting some labels in and then setting some titles, some tick marks from 2004 to 2024 since we kind of already know the time frame. Again, if we go back up here, typically it's starting from the year 2000 or so. And it's kind of just a stylistic choice at this point. And then our legend. So let's actually run it and see what we get. And oh my gosh, look at this. So this is our first ever, I'm going to move this tab down, our first ever visualization. And so we can kind of see the trend. So the green is Michigan State. So it looks like it was kind of low in the beginning and then it's increased. Same with Wisconsin and UMich. And it looks like overall I'm seeing a upwards trend. So it looks like people are getting better and better GPAs for these schools. And yeah, this is a pretty cool visualization. Let's move on to part 3.4 though, which wants us to modify the data being visualized. So let's see. They want us to modify the Y column to visualize the percentage of the freshman class that had a high school GPA of 3.75 or greater. And so if we go back here, remember that the thing that actually gave us the 3.5 is the column name, right? So what we're going to do is we want to look for the column name that shows greater than or equal to 3.75. So that's right here. And then let's go down, and we're basically going to modify this y column to be 3.75. And then we're going to have to run it again since we've updated it. Now that's 3.75. And then if we run this code again, it's going to look like this. So it's going to look a little bit different, but like overall we still see that same upwards trend. So it looks pretty good. And then this is the last test case. Let's take a run. All tests passed. Perfect. Okay. And then if we see down here, we have this section called JKLMNOP. Just keep letting me nerd out, please. So this is kind of like a little spot where you can kind of mess around or nerd out a little bit with the data. And so they have 2 challenges. And so I'm going to actually leave that to you guys to see if you guys want to maybe create a visualization that has all 10 schools. That would be pretty cool, having like, you know, all 10 of the different graphs to be able to see how things have changed over time. And so our last step is to commit our lab to GitHub and then run the autograder on it. Okay, so we're going to start by saving our work by doing File and then Save All. Let's do Save. Okay, and then we want to exit this notebook and return to this link right here called Commit and Grade Your Notebook. So let's go all the way down. Okay, so what we're going to do is to first commit our work. So this is something that we're going to use very frequently, but we want to start by doing the first command, git add -u, and then we're going to do the commit message, and then finally push. I'm just basically copying these all over back into my terminal, and then now that we've done this, let's do our grading. So it's kind of like the final thing. Let's visit our GitHub repository in our browser. So I actually have it pulled up already. And then what they want us to do is click on the Actions tab, okay, right here. And let's see, under workflows, find the workflow for this microproject. So under workflows, here it is, right? And then click the Run Workflow in the blue box, and then the green Run Workflow button. Run Workflow. So it looks like it was successfully requested. Okay, and then after about 10 seconds, we see the new job that has started running, and then we can actually watch it run in real time. So where is it? Oh, here it is. And so it looks like it's grading. It's going to probably take around a minute, so I'll come back when it's done and we can see what happens with it. Okay, so it looks like it only took 27 seconds, but here is our grading summary. And oh my gosh, look guys, we got 100%. Wow, and it looks like we've passed all of the different parts. And so if this is ever not a green check mark, we could probably just go back to the specific part. Like if we didn't pass part 3, we can go back to part 3 and see what happened. But we got 100%, so that's a good sign. And yeah, so that was our walkthrough of MicroProject number 1. I hope you guys enjoyed nerding out a little bit with the high school GPAs. And yeah, be sure to come back next week because I will be doing the second MicroProject.